Hello once again, and welcome to the spring review sessions for the examinations. Today we're going to be looking at data representation and helping you with some of those exam questions. So we're going to be looking at various types of questions that might come up in the examinations and giving you the tools to handle those questions well so that you do not feel nervous in the exams and you get all the marks that you deserve. Let's have a look at what we'll be dealing with today. The first thing are the bar charts, and then the histograms, the pie charts, and of course the interpretation of different kinds of data. In amongst the questions that I deal with today, we'll actually be looking at some other charts as well, but we'll get to those in a moment or two. So let's get straight to it. And here is a question that came from an examination paper. You can see it was February, March of 2010, a paper 1 question. And if you want to go and find this exam paper, it was question 2. Let's have a read through and see what it says. It says, Mr. LaRue publishes children's books. Initially, he published the children's books only in English. He now intends to translate the books into other official South African languages. The bar graph below shows the percentage distribution of the South African population according to official language groups. The population of South Africa was approximately 47,900,000 in 2009. So let's have a look at what that bar graph looks like. Over here you can see the heading at the top of the graph says distribution of South African population according to official languages. And there we have our chart. Let me point out a couple of features of the chart that are important for you to recognize. Firstly, on the left-hand side here we have the y-axis, and you see it has a label, percentage. Then at the bottom we have a list of the official languages, and you can see they start off here with Afrikaans, then English, isiNdebele, isiXhosa, isiZulu, Sepedi, and so on all the way through the 11 official languages of our nation. You can also see that on the chart we have a series of bars. And notice, this is why it's called a bar chart, these bars are separated by space in between the chart. So what we can assume straight away is that this data is not continuous data, but discrete data. In other words, each language does not follow on from the previous language. It wouldn't have mattered if we had put English first and Afrikaans second, or swapped any of these around, because they're simply independent headings for this chart. And that's why the bar chart is the representation that we've been given here. Later on we'll be looking at a histogram and seeing the difference. So I want you to note that difference straight away over here. Then if you look again on our y-axis at the percentage axis, you'll notice it starts off at 0 and moves up in increments of 5, 10, 15, 25 units at a time. Of course, we can see that actually it's moving up in units 1 at a time because there are smaller lines in between, and we can accurately read off the data from this. So the bars itself are all of different heights, and the different bar heights are indicating the different values in terms of the percentage that we've been given. You can see, for example, at the Afrikaans one here, it has a value of 14.3, and because it's percentage, we can say it's 14.3%. English, however, has a value of 8.6%. And notice the difference in the heights. They are proportional to the actual size of those values. So it's not just a random choice for how high we want to make these bars. They accurately reflect the size of the values or the data inputs that we've been given. Let's move on to the first question and see what they ask in relation to these charts. Question 1.1 says, which official language is spoken by the largest percentage of South Africa's population? Well, to answer this question, we need to go and look at which of the bars has the highest value or is the longest in its size. Well, if you're looking across the chart, I think you can clearly see that the isiZulu bar stands tallest amongst all of the bars and has a value at the top there of 23.8. So to answer the question, we're going to write, let's just give ourselves a little bit of space here, and we're going to write isiZulu. Now, I often find when answering questions from the bar charts, many students will go and put in 23.8% because they went to the chart and they said, well, that's the highest value. And yes, they're correct, but you're not answering the question. And in an examination, unfortunately, you will lose marks if you don't actually answer what the question is asking. So make sure that you don't just go and put in a value when the question's asking which official language. You must answer the isiZulu as the correct answer, even though your value is the correct value for the greatest value. Please make sure you do that carefully in the examinations. So on to question 1.2. Question 1.2 says, use the graph to list the official languages that are used by less than 5% of the population. Well, again, we need to go back and look at our chart. We're going to find where 5% is on the chart. And if you have a look over here, I'm going to highlight it for you. You can see over there is the 5% marking on the left-hand side. Now what I like to do is to take my ruler and put it on that 5% line, and what we can actually do is draw ourselves a nice line starting over here, and we're going to go all the way across, draw it across on the 5% line. We are looking for all the values that then fall below that line. So looking at our chart here, you can see this value over here, and let's circle it quickly. That one, this one, this one, and this one all fall below the green line that I've drawn on the screen for you. The rest are all crossing that line and reach above it, so they're not values that we are interested in. So the question asked which languages are used by less than 5%. We will have to mention isiHindebele. Let's just write that quickly. And then Siswati and Chivenda, and lastly Tsitsonga. Oh, running out of a bit of space there. Again, make sure that you answer the question by answering the languages that they've asked in the question. Question 1.3 says, what percentage of the population uses Siswati as an official language? Well, again, not a very difficult question. All we need to do is find where Siswati is on our chart and go and read off the percentage. But we have a small problem. Have a look over here. There's Siswati, and we see that there is no value for the percentage. So what are we going to do in this case? Well, it's not as difficult a situation, and they haven't made a mistake on the exam paper. Remember, they did tell us that this was South Africa's population. So we can make an assumption. If we have all the people of South Africa, the 47 million that are over here, we must assume that that is 100% of the population. That means that what we need to do is add up all the different percentages that we've been given over here. And to find this one, we'll take the total of all the ones we've added up and subtract it from 100%. We can make that assumption based on the fact that they told us that this is from South Africa's total population. So let's do that quickly. We need all those values, and let's start. We've got 14.3, 8.6, and 1.5. So 14.3, 8.6, 1.5, and then we need 17.6 and 23.8, 17.6, 23.8, 9.4, 7.9, and 8.2. 7.9, 8.2, and lastly we've got 1.7 and 4.4. Right, we need a total for all of those percentages that we've been given. The best way to do this to ensure that you don't make a mistake is to use your calculator. I'm just going to add up quickly for us, otherwise we'll take too much time. Let's add up the values that are decimals. 0.3 and 0.6 is 0.9, 1.4 that's 2, 2.8, 3.2, 4.1, 4.3, 5, 5.4. So we've got 0.4 already and still got 5 to add up. 5 and 14 is 19. 19 and 8 is 27. 28 plus 17 is 45. Plus 23 is 68. Plus the 9 is 77, and then we've got 7 there, so that's 84. 84 and 8 is 92, 93, and that makes 97. So altogether, we have 97.4%. Go and check the value on your calculator to make sure I've done it accurately. Of course, the total population we said was 100%, so we're going to say now we know that the total population represents 100% of the data that we've been given. And we know that 97.4% speak all the other languages, and to find the Siswati, we now need to say 100%. Let's just get our pen back here. 100% for the total population minus the total for all the others. And that answer comes out at 2.6%. Going back to our chart, we can go and fill that value in on the chart. Now notice that the size of that bar for Siswati represents 2.6% and looks like it does so as well. For example, if you were working your calculation and perhaps you came to this answer and you got an answer of, let's make it 77.4%. Then when you go and do your calculation of the 100% and you subtract, and we'll need to erase this one as well, we'll now subtract 77.4%, we'd end up with an answer of 22.6%. But going back to your chart, if this answer was 22.6%, you can see that our biggest bar, the one for isiZulu, was only 23.8%. This bar is way too small to represent an answer of 22.6%. And so in the examination, you can actually use the information on your charts to check whether your answer is actually realistic or not. We can see that from the bar size, a 22.6% answer would have been unrealistic for that size bar. So I always tell my students, if you get an answer that looks unrealistic or extreme, redo the sum. It's worth it in the exam, because this is actually a way of checking whether you've achieved the right answer or not. And it could have just been a simple addition that you missed a value to get an answer of 77.4. Just go and do the addition again, and in a short minute or so, you can actually fix the answer and therefore get all the marks for that question. Right, let's have a look at the last little bit of the question. Question 1.4 reads, calculate the number of South Africans that uses English as the official language. Well, now it's important to realize that they're asking for the number, not the percentage. We've been given a chart that gives us percentages. And when it comes to English over here, we can see English is at 8.6%. So we know that 8.6% of all the South Africans use English as an official language. But how are we going to find the number? To do that, we need to know how many South Africans there are. And right at the beginning of the question, they did actually give us that amount, 47,900,000. So what we need to go and do is find what is 8.6% of the 47,900,000 people. And to calculate that, remember, if we're saying 8.6% of, we're actually asking for a multiplication sum. So we're going to do a simple multiplication and say 8.6% times 47,900,000. And for this, I'm going to use my calculator because it's a far too big a number to actually work out in our heads. So we'll type in 8.6, and to find percent, remember, we can either divide by 100, or if your calculator has a percentage button, just press it. So there we go, that's 86 divided by 100, that's 8.6%. Now we must take that value and multiply it by the 47,900,000. When you've got so many zeros, make sure that you actually put in all the zeros. 47,900,000. Okay, and the answer comes out at 4,119,400. So let's write that over here. That equals 4,911,400 people that use English. There we go. And lastly, we have a 1.5 question, and it says, suppose that Mr. LaRue decides to print 100,000 copies of a particular book. Use the graph above to calculate how many of these books should be printed in isiXhosa. So he wants to do 100,000 copies. And we know that isiXhosa, which is right over here, there it is, can you see? 17.6% of the population use this language. So what we're really asking now is we want to know what is 17.6% of 100,000. Because the 100,000 represents the number of books that need to be printed in all official or 11 official languages. That means that a certain percentage of those 100,000 must be made into English, another lot must be made into Afrikaans, another lot as isiXhosa, Tshivenda, and so on and so on. The question is, how many? Well, we should use our information on the chart of how or what percentage of people speak the different languages to guide how many books we should print in those official languages. And so again, to find 17.6% of 100,000, we have to do a multiplication sum. This one is a little easier to do without a calculator, but just for accuracy and to be safe, we'll use the calculator anyway. 17.6. Again, we'll divide by 100, and then we're going to multiply by the 100,000. There we go. And the answer, 17,600 books. Great. Well, that's question number 1. We're going to move now to question number 2, which involves the use of a histogram. Again, the histograms and the bar charts are very easy to confuse, so let's take note today of the differences between these two kinds of charts. This question reads as follows. The histogram represents the weights of 60 babies, and 6 babies weigh from 4 to 4.5 kilograms. So we have a total of 60 babies represented in this chart, and we know that from 4 to 4.5 kilograms, there are 6 babies represented over there. Now, part 1 of the question, or 2.1, reads, which category of birth weight had the most recorded births? Well, again, we're looking at the height of the bars in this chart. Before we actually move on there, I want to just point out, notice that these bars are all connected. And the reason being that we actually only have one category here, and that's birth weight. It stretches from 1 kilogram right up to 6 kilograms. There's not separate categories represented as there were in our previous question where there were different languages. Here there's only one category split up into a variety of values, and the range of those values is from 1 right up to 6. It's a continuous set. So we can have anything that falls in between 1 and 6, and we can point it out on this chart. Back to our question, it says which category had the most recorded births? Well, the tallest bar that we have is this one over here, and that represents the category from 3 kilograms up to 3.5 kilograms. So we're going to fill that in as our answer. 3 to 3.5 kilograms. Again, remember to put in units when you're writing answers. Don't just write 3 to 3.5, because we have got some units that are given there, and we need to show that we understand where we got those from on the chart. Question number 2. 2.2 says, calculate the number of babies weighing less than 3 kilograms. Well, here's a tricky little question that involves some real working out. We were told that the entire chart represented 60 babies, and we were also given a category 4 to 4.5, and that represented 6 babies. So we know that this category over here, I'm going to just shade it in a little bit. This category over here is 6 babies. So what I really want to know is how many of these little increments from the bottom here all the way is equal to 6 babies? Or even better still, how many of those little bars do I need for 1 baby? Well, let's count how many we have here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks. Okay, and 12 blocks are representing 6 babies. So on my page here, I'm going to write 12 units equals 6 babies. Therefore, what does 1 unit equal? Well, 1 unit, what we're dealing with here is our ratio and proportion. If we know that 12 is equal to 6, 1 unit would be equal to 6 divided by the 12. Remember, to get from 12 to 1, we would have had to divide by 12. 12 divided by 12 is 1. Therefore, 6 divided by that same number must give us the ratio value here. And 6 over 12 can be simplified to 0.5 or a half. So 1 little bar on the chart, every little unit here, is a half a baby represented. Now, of course, that sounds terribly obscene to have a half a baby. Nobody wants to give birth to a half a baby. But remember, we're just talking values here, and we'll see from our chart that we're not going to deal in half babies as such. So let's count up the number of bars for a column. 1, 2, 3, 4, 5. There's 5 over there, so 5 times a half is 2.5. There we go. This one is also 5, so we can say another 2.5 over there. This column goes up 10, 11, 12. It's actually the same as that one, so we know straight away there's 6 babies over there. In this one, we've got 5, 10, 15, 20, 22 units. And 22 units is 11 babies. 22 times the half gives us 11. Now, we only need to go that far because remember our question said we were interested in all the babies that are weighing less than 3 kilograms. So this is the 3 kilogram line. We don't need to go beyond that, so we're not interested in all the data that goes on further in that column or those columns. So let's add up the values that we've got for each of these columns below 3 kilograms. It was 2.5 plus 2.5 plus 6 plus 11. And that comes to a grand total of 22 babies. So So 22 babies in this set of data weigh less than 3 kilograms on this chart. So let's go on to the next question. Now, I've incorporated something new into this question. It's something called a frequency polygon. And if you remember from your statistics or your data handling questions or section that you studied, a frequency polygon is a type of a graph or chart that we can draw to represent different types of data. And we're going to end up drawing one based on the information we were given here. This kind of question may not come in the exam. You might be given a frequency polygon, but you might have to fill in a chart where they give you certain values. I'm going to start from scratch so that you can see every little bit of the chart. But you will be helped along in the exam by being given certain values and maybe only have to calculate 1 or 2 values for yourself in the chart. So the question says, create a frequency table for the information in this histogram. Well, we've got a frequency density given to us here. We already filled in on the previous chart. This was 2.5, that was 2.5, this was 6, that was 11. Let's quickly do the rest of the chart in the same way. And we've got 5, 10, 15, 20, 25, 26. That means this bar is 13. Over here, 5, 10, 15, 20, that means 10, and 5, 10, 12, that means 6 again, and 5, 10, that means 5 babies over here, and this one's 4 and 4, so basically 2 babies and 2 babies. All right, we've got what each value represents in terms of baby numbers. So I'm going to fill in the frequency here. It's just those same values, 2.5, 2.5, 6, 11, and 13. So 6, 11, 13. The last couple, 10, 6, 5, 2, and 2. So 10, 6, 5, 2, and 2. Remember, frequency is just asking you how many times each of the values occurs in the categories that they've given. And the categories were nicely spaced out. We can see how much each one represents by working them out as we did earlier. We've got all our frequency values. Now, cumulative frequency simply means that what we're doing is we're taking the frequency and adding each one up as we go. So to start with, the first one will always be the same value, because we're starting from 0 and we're adding the first column in. 0 plus 2.5 is simply 2.5. In the next category, however, we're taking that 2.5 and we're adding it to the value that we have next, which is 5. 2.5 plus 2.5 is 5. Now we've got to take the next category, which is 6, and add it to what we've already got. 5 plus the 6 is 11. And so we go on. 11 plus 11, 22. 22 plus 13, 35. 35 plus 10, 45. 45 plus 6, 51. And plus another 5 is 56. Plus the 2 is 58. And plus another 2 is 60. So the cumulative frequency just keeps a running total of the values in each category. Again, we can check that we've got the right answer because they told us that the total was 60 babies. And sure enough, we've totaled up to 60 over here. So we can be confident that we've got the right values in our cumulative frequency chart. So question 2.4 says we need to create a frequency polygon from the information in the table in 2.3. So to start off, we'll need a set of axes. Over here on our left-hand side, we're going to have our frequency. And over here, we're going to have our weight again in the different categories. Weight in kilograms. And we need to divide. We've got 0 to 0.5. So starting at 0 there, it's 0 to 0.5. 0.5 to 1. No, sorry, let me erase that. Then we'll start at 1 again. 1 to 1.5, and so on, all the way to our last category, which will be 5.5 all the way up to 6. So we put all our categories on the bottom row there. Now we're going to need the data from the previous chart. I'm just going to go back there quickly so that we can point it out to you. Remember, we had from 1 to 1.5 was 2.5. So over here we're going to find 2.5, and we'll need a scale. What was the highest value that we had for our frequency? Well, that was this one over here, which we said was 13 babies. So I would suggest that for your frequency chart, start at 0 again, always good to start at 0, and move all the way up to, let's say, 15. That will give us a nice range of values. So where would 2.5 be? Well, round about there. And our first point is for the 1 to 1.5. So we're going to use right in the middle of that selection between 1 and 1.5. We'll put a single dot at halfway between 1 and 1.5 and all the way across to 2.5. Our next category, which was 1.5, let's just put it in here quickly to 2, also had a value of 2.5. Going back, we can get all the other values. Let's just use them here from our chart. 6, 11, 13, 10. Let's fill in all of those. So 6, 11, 13, 10. The next category was 6, about there. The next category was 11, about there. Oh, let's go a little bit higher. I'm just going to erase that one again. 11 is about here. We'll do the 6 again as well. 6 is a little bit higher, sort of about there. So 6 over there, 11 over there, 13, then we're down to 10. And so we go on plotting each of those categories. Let's just get the last couple. After 10 was again 6, 5, 2, and 2. So we're back down to 6 over here, then a little bit less 5, and 2, and 2. So to complete our frequency polygon, we're going to draw from the 0 and connect. Let me actually use a nice straight line rather than that skew one. It'll look a little neater. So we want a nice straight line starting at the 0 to our first value. Then from there up, then from there to the next dot, and so on, and so on. Basically playing a game of connect the dots. And you get this very odd little shape, which for the last category would end up like that. And that's an example of a frequency polygon. Well, you might say, what's the use of that? Well, it's simply a diagram to represent our frequency as we worked it out on the cumulative frequency chart. Of course, we could go a step further, and I'm just going to quickly explain this because it's useful in what we're doing. We could have drawn another chart for ourselves. And instead of drawing just frequency, we can draw cumulative frequency. Let's write that in quickly. Cumulative frequency. So again, we'd have all those categories. We'd go back to our chart and have a look at the cumulative frequency. Instead of plotting these values, we're now going to plot these values which steadily increase. That ends up giving you a curve which looks something like this. Starting down here at our low category, we'd put our first dot and then our next one and so on. The values keep increasing, and of course towards the top there was the 2 and the 2 that we add up, and we get a chart that looks something like this. A cumulative frequency chart. This one's useful for reading off various values of the cumulative frequency for the category. So for example, if we wanted to say what does or how many babies fall under the 4 kilogram line, we'd simply go here and say where is 4 kilograms on the chart. It might be over there, that might read 4 kilograms. We'd simply move up and say, right, let's draw a line. Let's use a straight one again. A line up to our curve, 4 kilograms. I think I've actually chosen a value that's too high, so let's just get rid of that one just for a sec. I'm just going to undo. So 4 kilograms would probably be around about here. Let's make a mark there. 4 kilograms. and drawing our line to find where it meets with our chart. We'd run across to here, and we could read the cumulative frequency off. And knowing from the previous example where we had our 3 kilograms and we said there were 22 babies, 4 kilograms would be another 13 plus 10. So you can even go and look on the cumulative frequency chart that we did previously to see if you were correct. But that would represent 51 babies. And if you go back and look at our chart over here, you can see that value is probably, if there was our 60, which is our total, let me just grab the pen again, 60, which is our total, that is about 51 over there. That's what we're reading off on our chart. That's just by the way, and something that you probably might see in an examination following on from the type of histogram that we had earlier. We're moving on to question number 3 now, which again is an exam question adapted from November 2010, paper 2, question 3. Mr. Ritt wanted to show his colleagues that the South African government was spending more on education than on most other departments. The 2 graphs below show the budgeted government expenditure for the financial years 2009 to 2010, as well as 2010 to 2011. The total expenditure budgeted in 2009-2010 was 834.3 billion rand, and for 2010-2011, 900.9 billion rand. And here we have 2 very nice pie charts which give us all the different information for the expenditure for government. You can see they've labeled different categories, A to H. There we have the same categories, A to H, and various percentages are listed. Below is a key which tells us what each category is, and of course the one we are interested in is education. So we're going to be looking at the E category in each of the pies. So that's this pie part over there as well as this one over here. That's 2009-2010, and this one over here is 2010-2011. So 3.1 says, show that the difference between the amounts budgeted for education for the financial years in 2009-2010 and 2010-2011 is more than 20 billion rand. Now, this is a very big question. You can see it counts for 8 marks, and they haven't given you much information. So they're really asking you to be on your toes and make sure that you do several different things to get all of those marks. Well, let's have a look at what they're interested in. We need to show the difference. Difference suggests that we've got to do some subtraction somewhere along the way between the amounts budgeted for education for the financial years in those 2 different years that they have. So we need to know what is the amount in 2009-2010 and what is the amount in 2010-2011, so that we can calculate the difference between those 2 values. Our problem comes in that we have not been told any amounts. Instead, they've given us percentages, and in the second one we don't even have the percentage for E. However, we were given the totals for each of the years. And remember that a pie chart always represents the total, or 100%. So 100% for 2009-2010 came to 834 billion rand. And 100% for the following year was 900 billion. So to work out the amount spent on education, we need to firstly go and work out what 17% is of the 834.3 billion. And secondly, we need to work out what percentage was over here so that we can find out the percentage of the 900 billion for the second year. Well, let's start by finding this percentage. We have several percentages given. We only have one that is unknown. So what we're going to do is simply go 100% for this pie chart, subtract all of these added up together. Let's add them up quickly. Let's start with A so that we don't leave any out. A was 10%, B is 17%, that comes to 27%. Add another 10 and we've got 37%, plus 11 is 48%, plus 15 is 58, plus the 5 is 63. 63 plus 4 is 67, and lastly we've got 15 left, so that brings us to 82%. So we want to subtract that total, which is 82%. That leaves us over here with E being 100 minus the 82%, and that comes to 18%. So this part of the pie is 18%. You can see that simple calculation is already going to give us some of those 8 marks that we have. You'll probably get about 2 marks for that sum. Now that we know the 2 percentages, let's go and work out the amounts, because that's what we need for each of the years. So for the first one, we need 17% of, and let's go and get that figure again, 834,3 billion. 834,3 billion rand. For the second one, and I'm going to do it just alongside here, we needed 18% of the second amount, and in this case it was 900.9 billion. So 900,9 billion. Right, so 2 different sums to get 2 different amounts. Make sure that you use the right amount for each of the years and you don't confuse the 2. Let's work out what 17% of 834,3 billion is. For this, we will need a calculator, so let's get our calculator ready here. And we're going to take the 17%, so we'll divide by 100, and now we'll take that answer and multiply it by our 834 billion. So that's 834.3, and to get billion we can simply use either that button over there, the x to the power of something, or even this one over here, which is times 10 to the power, and of course for a billion we need 10 to the power of 9. So close the bracket. That gives us this answer, which is 1.41831. So I'm going to write that over here. Let's just get our pen again and let's just check the answer. 1,4131, and that's times 10 to the power 11, or literally 141 billion rand is spent on education. To do the same sum for the other side now, we need the 18%, so let's clear that away. It's 18 divided by the 100 for percentage, and for that one we must multiply by 900.9 billion. So we'll multiply by 10 to the 9 again, and that gives us an answer of 1.62162. So 1.62162. 1,62162, and again it's times 10 to the 11, and both of these answers are in rands. So for 2009-2010 we've got that amount spent on education. For 2010-2011 we've got this amount spent on education. Of course, the question again said we need to find the difference. So we've got to subtract the highest amount from the lowest amount. Well, which amount is highest and which amount is lowest here? We can see that 1.62 something is bigger than 1.41 something. So we're going to put this number first, and let's write that there. 1,62162 subtract 1,41831. Both of these are times 10 to the 11, times 10 to the 11. A quick word of warning over here. You might be tempted to want to round these answers off and say 1,6 minus 1,4. The problem with that is that because of this very large 10 to the 11 power factor here, you cannot ignore all the decimal places. You must keep every one, because this amount really represents a very large amount of money. So even that factor over there, the 1,41831, that last one over there is already, that one represents 100,000 rand. So we need to make sure that we keep all the decimals. So again, back to the calculator, let's type those amounts on and then we can do the subtraction. I'm going to clear it again. We've got 1.62162 4.62, and that's times 10, let's just clear that quickly, times 10 to the 11. And then we're going to subtract, and let's put the next one in brackets, 1.41831, and also times that by 10 to the 11, and let's put in the 11 over there. And that gives us an answer of 2,0331 times 10 to the 10. So that's 2,0331. 2,0331 times 10 to the 10. And again, the answer's in rands. Well, going back to our question, remember our question asked us to show that the difference was more than 20 billion rand. Now, our answer is 2,031 rand times 10 to the 10. Let's check if this is actually more than 20 billion. What is 20 billion if I write it in scientific notation? That's 20, let me just erase that. 20 and billion, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, to write a number in scientific notation, we need to write the number as one number and a comma. So our comma actually has to go right over there. So we're going to start off, let's give ourselves some more space, with 2, comma, and of course it's 0, 0, 0, 0 all the way, so we don't need to worry about the zeros. We can maybe leave it as 2, 0 if you want to, or even just 2, but we must multiply by a factor of how many places we moved our decimal. Remember, our decimal would have started over here if we were carrying on writing numbers. We've taken our decimal and moved it all the way there. So how many places did we move it? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So that's times 10 to the 10. So to write 20 billion, we would write it as 2 times 10 to the 10. We got an answer of 2,0331 times 10 to the 10. And this number with the 0,331 over it is bigger than that number. Our 10 to the 10s are the same, so we can make a direct comparison between these numbers. So we have shown that the number that we got as a difference between those two amounts is slightly bigger than 20 billion rand. And therefore we've actually answered that question. Great, let's go on to the next part of it. 3.2 says give 2 possible reasons why you think the South African government should increase its budgeted expenditure for education. Now here's a question that doesn't have a right or wrong answer. Or should I say this, it doesn't have a completely right or completely wrong answer. You can give your opinion. Of course, you may not have an opinion that is actually suited to the question, and then you're not going to get marks for the question. However, you have got a variety of answers that you could possibly give. And that's why this is a paper 2 question. Remember, we said this came from paper 2. These kinds of opinion-related questions give you an opportunity to think in relation to the question and to give possible suggestions. So what reasons would the South African government have to increase the budget from one year to the next for education? Well, can you think of any? Just off the top of my head, I would imagine that there's maybe a large population of children coming into schools. Perhaps the population has increased. So you could write for one of the reasons, and let's give it a number. An increase in schoolgoers or pupils would need a greater budget. So if you had more pupils going into schools, it stands to reason that more money would be needed to educate those children. And there you've got a good reason why the government would want to increase the budget. A second reason, well, we all know that prices increase on a weekly or monthly basis, don't we? If you go to the shops, you don't pay the same price as you paid last year for items that you might want to shop for. And teachers, being teachers, need to be paid a salary by the government. So if the government wanted to increase the salaries of the teachers, they've got to find more money for those teachers. And the only way to do that is to increase the expenditure so that they can actually increase salaries. So another wonderful reason would be to increase salaries for teachers. These might be two reasons of many that you could possibly suggest, but you need to think about the question and answer the question in relation to the information that you've been given. So make sure that when you do answer these questions, you are thinking clearly and logically, and read your answer back to yourself when you have written it to see, does it make sense? Would that be a suitable reason for why the government might want to increase salaries? Remember, we're not saying that's why the government did increase the expenditure. We're just saying they could have done it for those reasons. It's a suggestion, not a finite answer or a set answer. Let's move on to our fourth question. We're just about there now. And this question is going to be a nice one, looking at a misrepresentation of data. So again, we have a nice bar graph here. We can see it's a compound one. Examine the bar graph below and answer the questions that follow. Well, there's our bar graph. We can see again a heading, number of passengers carried in millions. We have the number of passengers carried nationally and abroad by African Airways from the years 2000 to 2003. And there we can see the different years listed below. We can see it's a bar chart because there's space in between the data. All the things we are now quite familiar with. 4.1 says, what is the difference between the number of national passengers and international passengers carried in 2003? So we are interested in this here over here. There's 2003. We can see from our key that the national flights are these ones, and the international flights are the closest spaced dots. So how many international passengers were there? Well, having a look over here, if I take a line from there all the way through, this is 4.8, and remember, it's 4.8 million because they said it is in millions. So we've got 4.8 million international passengers. Let's just erase that quickly and use our pen. 4.8 million. And then we need to know how many national passengers there are. Well, you could go up here and you could say, look at that, 6.2 million. But hang on a moment. Notice that the national passengers start at 4.8 million. So there aren't 6.2 million passengers from that level to that level. This part of the chart does not start at 0. So what we need to do to find the number of national flights is say 6.2 minus the 4.8. So for our national passengers, we need to have 6.2 million minus the 4.8 million. Let's just put an M for million, and that comes out to 1.4 million passengers. So we have 1.4 million passengers represented by this part of the bar chart. Of course, the question, we're not completed yet. We need to actually find the difference between those amounts, and that means we've got to take the 4.8 million for the international passengers and subtract the 1.4 million for the national passengers. So the difference in those amounts is 3.4 million passengers. And that then answers the question, which says what is the difference between the number of national passengers and international passengers. So far so good. Let's move on to part 2 of the question. 4.2 asks, what is the ratio of national passengers to international passengers carried in 2003? Well, we've already done part of this question. We can use the values that we already calculated. Remember, we had 4.8 million international passengers and 1.4 million national passengers. So we want to find the ratio of, and let's go back to the question, the ratio of national to international. That means we must put the national ones first and the international passengers second. Well, we said 1.4 million nationals as to, that's the standard notation for the ratios, to 4,8 million. And remember, we don't leave ratios with such large numbers. We try and simplify those numbers as far as possible. The quickest way to try and simplify is to see, will this number, the lower number, divide into the larger number? Let's try and see what we get on the calculator. So clearing our calculator, we've got 4.8, and million is times 10 to the 6, divided by 1.4 times 10 to the 6. That gives us a ratio of 24:7. Okay, that's not a whole number, so I'm going to try and make it slightly simpler for you. Well, the first thing we can do is we can scrap the millions, because there's millions on both sides, so we can ignore them. So our number can reduce to 1.4 as to 4.8. Now, if we have decimals, we also don't like those. So I'm going to just take every number and multiply it by 10 quickly, and that will give me a 14 as to 48. We can see that both of those numbers are even, so let's halve them, and we've got half that is 7, half that is 24. You can see that actually our calculator answer was really giving us the values of the actual ratio in its simplest form. 7 as to 24. And that's as simple as we can go, because we cannot go smaller without going into decimals, in other words, things like the 1.4, and we'd like to avoid decimals when we're writing a ratio. Great, so now we have the ratio of those passengers. Let's look at question 4.3. Question 3 says, does the airline carry more national or more international passengers? Now, if we look at the graph, you can see that the shaded areas for nationals, the light ones, look quite a bit larger than the shading for the international passengers. And you may be tempted to say, well, the diagram is clear. It tells us that the national passengers are far more in abundance than the international passengers. However, even in our previous sum, we saw that there were 4.8 million international passengers and only 1.4 million national passengers. How can the graph then look so wrong? Well, it comes from this fact. Notice that the graph started here at 3.8 million. This over here, let's just get a pen again, is 0 million. So from 0 to 3.8 million is represented by a very small section. Whereas here we're only representing 200,000 by the same section. This part is not equal to that part over there in terms of size. And that's why this data is misleading to some extent. From the chart, however, we must interpret that there are far more international flights, because we've got all the way from here, 0 to 3.8 million. That little bit over there represents 3.8 million passengers, as does that. This is 4 million, and this one was a whopping 4.8 million passengers. These ones over here do not nearly represent as many. Look here, we've got 3.8 million up to about 4.5 million. We don't even have a full million there. This little bit over here is only 700,000 people. Definitely a lot smaller than the 3.8 million that were represented for the international flights. So to answer our question over here, we've got to say that the international flights are international passengers are more. than national. So be careful when you are looking at a chart. Again, make sure that your scale has gone all the way down to 0, and don't be fooled by what looks as if they are trying to let us see that the national passengers were actually more. And our last question on this one actually follows on from that, and it says, explain what message this chart wants people to believe about the statistics and how it has achieved this. So again, a two-part little question here. What do they want us to understand, or what are they trying to convince the readers of this chart of? Well, the chart looks like there's been a large increase in the number of passengers, and particularly that national flights seem to have increased quite significantly because they're on top. So you can write that. You can say, they want us to believe that there is a large increase in passenger numbers, particularly national flights. Now, that's the easy part of the question. How have they actually achieved this? Let's give ourselves some space there again. Well, two things. They started the scale at 3.8, or just below 3.8 million. So what they've done is not start the scale at 0. So the first thing you can say is the scale does not start at 0. And what does that do to our chart? Therefore, it exaggerates the data. You see, if we had started at 0, these columns over here would be much taller. And with tall columns, let me try and draw it for you here quickly. If we had very tall columns starting about there, then the next column would have only been slightly bigger, and the next one only slightly bigger than that. That doesn't look as sharp an increase, if you look like that, as what this one does, which seems to go like that. So by exaggerating or by limiting the scale, they have made this increase look like it is far bigger than it really is. The other thing is they've placed the national flights on top, so we can write that. National flights were on top of the chart, making it look as if they increased significantly. Just going back to our chart, you see the height of this chart looks as if the national flights have increased significantly, but look at the size of our national flights. Again, the sizes aren't very different to each other, and there's not really been a great change in the number of national flights. So again, this chart is slightly misleading. Now, charts like this are used to, if a company wants to present data and they want to look good in the books with their shareholders, they might go and do something like this so that their shareholders believe that they're doing very well. In the meantime, they're not really being completely honest with their shareholders. So it is important, if you are involved in a company, that you check things like this. And if you go and look through many magazines or newspapers, you'll often find that these types of charts come across there to make people believe certain things. So a wonderful question on misrepresentation of data, and one that is certainly typical of examinations. We're on to our very last question, And this is question number 5. Here we have a graph taken from the Star newspaper in August 2011. Let's have a look at what this bar graph does. And it's a very nice example of a compound bar chart. On the left-hand side, we have percentage of people who have responded to a questionnaire. And on the bottom, we have several categories of financial information. For example, whether people updated their will during the past year, whether they have a medical insurance or medical aid, whether they have life cover, retirement provision, an emergency fund. And so these are questions that might have been gotten from a questionnaire, and here we have all the people who responded to that questionnaire, and we have a bar chart giving us all that information summarized. So let's have a look at the question. Question 5.1 says, what percentage of people took out medical insurance with a financial advisor? Now, the key says that the blue is with a financial advisor or planner, and the pink is without a financial advisor or planner. So we need to go and look at medical aid, which is this column over here. And you can see the blue with a planner says 96%, without 81%. We want to know that the ones that did take with a medical advisor, a financial advisor. And so we are interested in that 96% over there. So the answer, simply 96%. They asked us for the percentage in this case. Question number 2. What percentage of people had life cover but without having used a financial planner in getting that life cover? Again, we'll have to go and look at the category life cover, that's over there, and this time we're interested in the ones with no planner, so that would be 80%. Nice and easy. These are generally typical of the paper 1 questions where you've just got to read information off the chart. Make sure you use the right categories and that you read accurately so as to get all the marks, because often students throw away marks by perhaps reading the wrong category even though they know how to answer that question. Question 5.3, what is the difference in percentage between the people who use the financial advisor and those that do not when providing for retirement? Again, we need to go and look now at the retirement provision, and we want the difference between those who did use a planner, which in this case was 58%, and those who didn't, which is 42%. So we'll do just a small sum over here, 58% minus 42%, and that comes out to 16%. So the answer is 16% is the difference. Question 5.4, explain what message this chart wants people to believe about the statistics and whether it succeeded or not. Now this again is a typical paper 2 question because it's asking for some interpretation and it's asking you to give an opinion. Well, if we look at this chart, why do you think they put it together? Notice that everywhere along the chart, the blue bar graphs are higher than the pink bar graphs. And what they're suggesting is that people who have made financial provision in all of these areas did so with the help of a planner. So a possible suggestion for the answer to this question is that the chart wants us to believe that planners are necessary in purchasing financial products. Or you could have possibly said that more people are likely to actually go and buy financial products when they do so with a planner than those that do not. And that would be the kind of thing that this chart would give us. Of course, any financial institution, such as maybe Liberty Life or Old Mutual, who do financial planning, they would have used a chart like this to tell people that it is a good idea to use one of their companies so as to do their financial planning for those people. And let's see, do we have another question over here? I think we do. So 5.5 says, explain why a pie chart was not used to represent the information in this chart. Now, you see percentages and you might be tempted to think that, well, a pie chart could be used for this. But now you're saying, well, the question says I must say why we shouldn't use a pie chart. Can you think of a reason why we wouldn't take these percentages and represent them in a pie chart? Well, the answer is simply this. Each of these categories are not a portion of a whole. We're not looking here at 100% of, say, what types of products the different respondents used. We're not saying that of 100% total, some used updated wills, some used medical schemes, some used life cover, some used retirement provisions, and so on and so on. What we're saying is here that of each of the people, one person could have had all of those products. And you can see it even from the figures. Here we have 74, there we have 96. That's already much greater than 100%. We're not interested in a total percentage because each person here could have responded to each of the categories in these lists that we have. So to answer this question, we need to say the percentages do not represent and here's a good word to use in this answer, a fraction of a total percentage. That's why the pie chart in this case will be of no value to us in this diagram. Well, there we have some exam type questions. I trust that you're going to make use of these and learn from them, and I wish you all the best in those exams that are coming up. Go and study. It is worth it for your future.